Hello students, in this class we will learn about polynomials. We use polynomial in our mathematics, but we don't know what is the actual meaning of a polynomial. Okay, like you all know this kind of algebraic expressions like 3x squared plus 2x minus 1, 4x cubed plus 7x squared plus 2x plus 1. Okay, you already introduced with these algebraic expressions, but you don't know what is the actual meaning of a polynomial. Okay, so before studying about polynomial, we have to know its definition. That means what is the actual meaning of a polynomial. Polynomial is an algebraic expression in one or more variable where all the powers of the variable are positive integers and coefficient of the terms are all coefficient of the all terms are real numbers. In example 1, 3x squared plus 2x minus 1, all the powers of the variable x are positive integers and the coefficient of the terms are 3, 2 and 1 also. They all are real numbers. Okay. Similarly, in example 2, 4x cubed plus 7x squared plus 2x plus 1, all the powers of the variables are positive integers, that is 3, 2, 1, etc. They all are positive integers. And the coefficient of the terms that are 4, 7, 2, 1, they all are real numbers. Okay. So, what do you mean by polynomial? A polynomial is an algebraic expression in one or more variable where all the powers of the variable are positive integers and the coefficient of all the terms are real numbers. Okay. Now, we have to know the general form of a polynomial. General form of a polynomial. F of x equals to a n x to the power n plus a of n minus 1 into x to the power of n minus 1 plus a of n minus 2 into x to the power of n minus 2 plus continuing plus a2x squared plus a1x plus a0, where 0, 1, 2 up to n are positive integers and a0, a1, a2 up to an are real numbers. Okay, so this is the general form of a polynomial. So why this is polynomial? Polynomial means the algebraic expression where the powers of the variables are positive integers and the coefficient of the terms are real numbers. Okay. Poly means more than one, we can say. Okay. So that means in example 1, the number of terms are 1, 2 and 3. In example 2, number of terms are 1, 2, 3, 4. Okay. So more than one terms are present. That is why they are known as polynomials. Okay. So depending upon the presence of number of terms, polynomials are so many kinds of. Depending upon the number of terms, polynomials are so many kinds of. When number of terms equals to 1, then it is known as monomial. Example: f of x equals to 5x to the power 4. When number of terms equals to 2, then it is known as binomial. Example: g of x equals to 7x plus 5. When number of terms equals to 3, then it is known as trinomial. Example: p of x equals to 7x square plus 9x plus 2. When number of terms equals to 4, then it is known as quadrinomial. Example: q of x equals to 3x to the x cube plus 7x square plus 5x plus 1. Okay. So when number of terms is 5, then it is known as pentanomial and continuing. Okay. So polynomial means the algebraic expression which contains more than one term. And when there are some specific number of terms, then we can identify those polynomials as monomial, binomial, trinomial, quadrinomial, etc. Okay. Now we have to learn what do you mean by degree of a polynomial. Okay. Degree of a polynomial represents the highest power of the variable present in a polynomial. So what do you mean by degree of a polynomial? Degree of a polynomial is the highest, represents the highest power of the variable present in a polynomial. Okay. Example. Highest power of the variable is 2. So degree of the polynomial equals to 2. Highest power of the variable is 3. So degree of the polynomial equals to 3. Okay. If a polynomial f of x equals to 7, then we can write it as f of x equals to 7 into 1, that is equals to 7 into x to the power 0, because we know something to the power 0 is equals to 1. That is why if f of x equals to 7, then we can write it as f of x equals to 7 into 1, that is f of x equals to 7 into x to the power 0. So its degree is equals to 0. Okay. Students, we'll see the general form of the polynomial is f of x equals to a n x to the power n plus a of n minus 1 into x to the power n minus 1 plus a of n minus 2 into x to the power n minus 2 plus continuing plus a2x squared plus a1x plus a0. Okay, so where f of x represents the functional form of a polynomial. Okay, so this functional form can be written as f of x or g of x or p of x, etc., where x is the only variable, where x is the only variable. Okay. So we can take some examples. Like example 1, f of x comma y equals to 7x square plus 9xy plus 2y square. Then this represents a polynomial with respect to two variables. Here f of x comma y, x represents x and y, both are variables. Okay. In example 2, g of x y z equals to 10x square y plus 3yz square plus 5z cube. Then this represents a polynomial with respect to three variables. Okay. But here we will learn about a polynomial with respect to one variable. Okay. So our actual goal is to learn about a polynomial with respect to one variable. Okay. Now we will identify how an algebraic expression can represent a polynomial. Okay, that is why we consider two algebraic expressions. They are f of x equals to 7x square plus 3 by x plus 1, and in example 2, g of x equals to 2 by x cube plus 3 root x. Okay, we have to check whether these two represents a polynomial or not. Okay, so in example 1, f of x equals to 7x square plus 3 by x plus 1. This can be written as 7x square plus 3x to the power 1 minus 1 plus x to the power 0 in place of 1. As we know, something to the power 0 represents 1. Okay, so here powers of the variables are 2, minus 1 and 0. That is, all the powers are not positive integers. Because minus 1 represents a negative integer, that is why all the powers are not positive integers. So f of x is not a polynomial. Okay. In example 2, g of x equals to 2 by x cube plus 3 root x, which can be written as g of x equals to 2 into x to the power minus 3 plus 3 into root x means x to the power half. Here powers of the variable are minus 3 and half, which are not positive integers. So g of x is not a polynomial. Okay, now we will learn how we can find the value of a polynomial at a certain point. We can find the value of a polynomial for a particular value of the variable. Okay. If f of x equals to 7x cube plus 3x squared plus 1, find f of 1, f of minus 1, etc. Okay, so f of 1 means f of 1 f of 1, f of minus 1 means the value of the polynomial at x equals to 1 and x equals to minus 1 respectively. Okay, so here f of x equals to therefore to find f of 1 we have to put 1 in place of x. One cube means 1 plus 3 into 1 plus 1. 7 plus 3 plus 1. That is 11. F of minus 1. That means we have to put minus 1 in place of x. So thus we get a 7 into minus 1 whole cube plus 3 into minus 1 whole square plus 1 equals to 7 into minus 1 plus 3 into 1 plus 1. That is minus 7 plus 3 plus 1. That is minus 3. Okay. So by this way we can find the value of a polynomial at a certain value of x. Okay. Suppose there is a problem by this way. If f of x equals to 3x squared plus 7x, then find f of x minus 1. Okay, so to find f of x minus 1, we have to replace x by x minus 1. Solution. To find f of x minus 1, we have to replace the variable x by x minus 1 in the given polynomial. So since f of x equals to 3x squared plus 7x, Therefore, f of x minus 1 equals to 3 into x minus 1 whole square plus 7 into x minus 1. By simplifying this, we can write x minus 1 whole square as x square minus 2x plus 1, 3x square minus 6x plus 3 plus 7x minus 7. So this will give 3x square plus x minus 4. Okay. So this is the value of f of x minus 1. So in this problem, we learn how we can find a polynomial f of x as f of x minus 1. So to find f of x minus 1, we have to replace x in the given polynomial by x minus 1. Okay. Depending upon the degree of a polynomial, polynomials are so many kinds of, which are as follows. When degree is 1, then the polynomial is known as linear. Example: f of x equals to 7x plus 1. When degree is 2, then the polynomial is known as quadratic. Example: p of x equals to 5x squared plus 9x minus 2. When degree is 3, then the polynomial is known as cubic. Example: g of x equals to 7x cubed plus 2x squared plus 3x plus 1. When degree is 4, then the polynomial is known as biquadratic. Example, q of x equals to x to the power 4 plus 2x cube plus 3x square plus 5x plus 1. Okay, so depending upon the degree of a polynomial, polynomials are so many kinds of, which are as follows. When degree is 1, then the polynomial is known as linear. Example, f of x equals to 7x minus plus 1. When degree is 2, then the polynomial is known as quadratic. Example, p of x equals to 5x square plus 9x minus 2. When degree is 3, then the polynomial is known as cubic. Example, g of x equals to 7x cube plus 2x square plus 3x plus 1. When degree is 4, then the polynomial is known as biquadratic. Example, q of x equals to x to the power 4 plus 2x cube plus 3x square plus 5x plus 1. Okay, so depending upon the degree, we can distinguish a polynomial by this way. Now, what do you mean by zero polynomial? Zero polynomial means a polynomial whose value is 0. That is, if f of x equals to 0, then it is known as zero polynomial. Okay. Now, how we can find the degree of a zero polynomial? Since f of x equals to 0, then we can write it as f of x equals to 0 into x, or f of x equals to 0 into x squared, or f of x equals to 0 into x cube, or 0 into x cube, etc. That means there is no definite representation of this polynomial f of x equals to 0. That means when we represent f of x equals to 0 into x, then its degree is 1. When we represent f of x equals to 0 into x squared, then degree equals to 2. When we represent f of x equals to 0 into x cube, then degree is equals to 3. That means there is no definite degree of a zero polynomial. That is why the degree of a zero polynomial is not defined. Okay. That is, there is not a definite degree of a zero polynomial. That is why thus we can write degree of a zero polynomial is undefined. Okay. Again, if there is a constant polynomial, again, if there is a constant polynomial, as f of x equals to 7 or f of x equals to -5, then we can write them as f of x equals to 7 into 1, which imply f of x equals to 7 into x to the power 0. As we know, something to the power 0 equals to 1. Or f of x equals to -5 can be written as f of x equals to -5 into 1, which also can be written as -5 into x to the power 0. So the highest power of the variable becomes variable x is 0. So degree of a constant polynomial is 0. Okay. So if f of x equals to 0, then it is known as zero polynomial. Now we have to learn how we can find the degree of a zero polynomial. Okay. So since f of x equals to 0, then we can write it as f of x equals to 0 into x, or f of x equals to 0 into x squared, or f of x equals to 0 into x cube, etc. So in this first case the degree becomes 1, and in this second case degree becomes 2, and in the third case degree becomes 3. So that is why there is not a definite degree of a zero polynomial. Thus we can write degree of a zero polynomial is undefined. That means when there is a zero polynomial, that degree will not be defined. Okay. Again, if there is a constant polynomial as f of x equals to 7 or f of x equals to -5, then we can write them as f of x equals to 7 into 1 or f of x equals to 7 into x to the power 0. Again, for the second case, that is f of x equals to -5, f of x is equals to -5 into 1, this implies f of x equals to -5 into x to the power 0. So the highest power of the variable x is 0. So degree of a constant polynomial is 0. Okay.